Okay, this is the wiring for a double phase AC panel. This is the wiring for a double phase AC panel. And today we are going to talk about that specific wiring and specifically in the connection of the gauge, the amps, the volts, and the frequency. And you see what is the element that we are going to introduce in order to connect the ammeter in AC panels. What is the element that we need added?
The donut.
The donut. What is the function of the donut? If this is the ammeter, in the back you have two terminals. In the back of the ammeter you have two terminals. And if you have the donut, this is the donut, you have two cables. And those two cables are connected in the back to each terminal of the ammeter. Internally, the donut, look, I disassembly one donut. It's a coil. With the beginning of the coil is one of the cables, and the end of the coil is the other cable. Yeah? With that coil around iron donut, the coil is around the iron donut. You can sense the amount of cycles per second, and you can read amps. That you understand, guys?
Yes.
With this coil, and what cable I am going to pass through the donut? What cable? Hotline, neutral, or ground?
Hotline.
The hotline, because the hotline is the wire with the power, with the current, with the cycles. Yeah, we are going to insert the hotline. We are going to pass the hotline through the middle of the donut. Everybody follow me? This is exactly the same like the clamp to read amps in AC. This is the donut, and this is each terminal of the donut will be connected in the back in each terminal of the ammeter. Tomorrow in the lab I am going to explain again. Okay, guys. In this particular case, if you see the example that I have on the screen, we have a double phase. We have a double phase wiring. Check the wiring, because I am going to ask a couple of questions about that wiring. Okay. All right, we are going to check in details the connection of the breaker. You see the breaker, Danny?
Yeah, I see the breaker.
Okay, perfect. We have double breakers on top, and in the bottom, single breakers. And we have one group of breakers on the left side and other group of breakers in the right side. I have a question, guys. Why this configuration with the same amount of breakers in both sides is good? It's good idea. It's good design.
So you have an even load.
Correct. The idea is try to keep both phases with the same load. What is the symptom in a boat when you have one load with one phase with more load in comparison with the other phase? What
you
is
hear the generator knock.
Excuse me?
The generator knocks.
The generator knocks. That's correct. The generator is knocking. The stator tries to touch the rotor. Why that situation is dangerous for the generator? Why, when the generator is knocking, it's possible that you destroy the back end?
Because the stator's not supposed to be moving back and forth. It's
not
uneven.
Back and forth. It's because the rotor suddenly touched the stator and produce a short and destroy the winding.
Oh.
This is catastrophic. And you know how much is the price of the generator, no?
It's very expensive.
Only to keep in mind, when some customer asks to you about the price of a generator, the answer is $1,500 per each kilowatt. If you need a generator of 10 kilowatts, you need $15,000 for that generator. That's okay? It's $1,500 per each kilowatt. This is the price of any type of generator. Yeah, it's clear? Any question until that point? Okay, for that reason, knocking on the generator is an indication that you have unbalanced the phases. You have more load in one phase in comparison with the other. For that reason, in this particular wiring, we are going to install ammeter, voltmeter, and frequency meter in each phase. In order to verify, if you are the engineer of the boat, you open the cabinet, you see the gauge, and you can verify if the consumption in amps in each phase is pretty similar to the other one. The same with the voltage and the same with the frequency. Okay, guys? Good?
Mm-hmm.
Is clear the picture? For
Yes.
example, you have the phase number 1, the black one, and you have the donut, the black donut, and you see that the cables coming from the donut enter in the ammeter. Exactly the same with the red donut. The hot phase, the red phase, pass through the donut, and the small wires, the orange wires, enter in the ammeter. This is the procedure to connect the ammeter in the phase. And this is exactly the wiring that we are going to do in the project. Any question about the connection of the ammeter, guys?
No.
No. Okay.
I have one question.
Go ahead, Papa.
So since the phase 1 or phase 2 wire is going through the donut, what happens inside the donut? Like, how does it pull the amps from the wire if it's not actually attached? Like, what happens in the donut where it reads the amperage? Like, how does it do that?
Oh, internally, because you remember the coil, that coil?
Mm-hmm.
That coil? The coil is passing around the iron, and the iron will be magnetized, and half of the iron will be positive and the other half will be negative. Each time that one cycle passes in front of both magnets, the magnets read one cycle, and the next cycle, other cycle. Depending on the amount of cycles, the small computer internally in the gauge sends the flow of amps per minute or the flow of amps per hour. This is simple. It's because a couple of magnets. When the coil passes around the iron donut, produce half positive and half negative. When the current passes in the middle, the magnet sends how many cycles pass per minute. That's simple. This is the procedure.
So the wire makes the current. It makes the magnets magnetize.
No. Those magnets. Of course. When the current passes in the middle, immediately the magnets are magnetized.
Okay.
That's correct. When the current is not passing, the magnetic properties go down. That's correct.
Okay. Thank you.
Yeah, it's nice. Any other question about the connection of the ammeter? Tomorrow I am going to bring that one for the class, and we are going to check that one. And also we are going to explain with more details in the lab. But I want that you understand that picture, because this is the wiring that you need to use in the future if you wire a boat, especially if the boat is double phase. What about the voltmeter? How you remember how is the connection of the voltmeter in the DC panel? You remember in the previous project?
Attach it to the positive bus bar.
Okay, one leg to the positive bus bar and the other leg to the negative bus bar, no?
Yeah.
Correct. Here is the same. If you have the voltmeter, one leg will be connected to the positive bus bar, the black one, and the other leg will be connected to the neutral bus bar. One leg to the hot, and the other leg to the neutral. The same in the other side. One leg to the hot line and the other one to the neutral. That's it. It's simple. The voltmeter is too simple. One leg to the hot bus bar, the black hot bus bar, and the other leg to the red hot bus bar. And the neutrals, all the neutrals are going down, and they are connected. They are connected into the neutral bus bar. All of the neutrals, they converge in the neutral bus bar. This is the neutral bus bar in the bar. And we have another bus bar, is the ground bus bar, the AC ground bus bar. Be careful because this one is AC ground bus bar. You remember in the DC panel, we have the negative bus bar. In the AC panel, we have AC ground bus bar. Ground bus bar. Questions until this point with the neutral and the hot and the ground bus bar. No question, guys? You are a genius. In this oral test at the end of the class, Danny, there are
It seems like I guess we're doing our job right because they know everything, right?
Yeah.
We're geniuses. No Hialeah mechanics here.
Remember, remember that the final exam is oral with Mr. Rodriguez and me in the board. And in this particular board, we have more questions in comparison with the previous one, because we have more topics. It's okay? Okay, guys? All right, I have a question. How is the connection? Is clear the connection of the voltmeter and ammeter? Guys?
Yes.
Okay, perfect. For the ammeter in the AC panel, you need the donut, no? And the donut is passing through the hot line, through the phase. And the voltmeter is connected directly, one leg into the hot bus bar and the other leg into the neutral bus bar. Normally, in the back of the gauge, they say hot and neutral, or they say positive and negative. I don't like when they mark positive and negative because, in my opinion, positive and negative should be exclusive for DC, not for AC. In AC, you don't have positive and negative. You have hot line and neutral. That's correct?
Yep.
Okay. And don't forget that the neutral is the return. The neutral is the return of the current in AC current. Okay, now we are going to connect the frequency gauge, frequency, hertz, frequency.
Mr. Lopez.
According with this picture, according with the picture that you have in your screen right now, how is the connection of the frequency meter with respect to the voltmeter? Is
parallel.
In series? Is in parallel?
Parallel.
Is in parallel. Is in parallel because the hot is with the hot and the neutral with the neutral. Yes or not?
Yes.
Okay, it's pretty simple. Tomorrow, with a short power cable, we are going to use the multimeter to read frequency, to read the frequency of the building. And if you want, bring your multimeter, and we are going to practice reading frequency in the outlets of the building. Okay, my friends? Okay, this is important. We are going to use the multimeter to read frequency all the time. Basically, when the boat is running in generator mode, in some cases, it's necessary to calibrate the frequency. I am going to explain the procedure to calibrate the frequency. It's too simple. And this is nice. Believe me, my friend, the next topic that I am going to start to explain tomorrow, and we continue on Thursday, is the generators. And in generators, this is, in my opinion, the area of the marine field where the people make more money. The people dedicated to generators make a lot of money because the troubleshooting is not easy. It's not complicated, but you need a lot of attention. You need a lot of I don't know in English you say a lot of mucho cuidado, no, Danny?
You got to pay attention to the details.
And details. That's correct. This is the element. This is a vital element in a mega yacht in a mega yacht, if you don't have generator, it's impossible to move the boat because of the bow thrusters are not DC, are AC. The majority of the elements are AC. If the generators are broken, it's impossible to use the boat because you don't have air conditioning, you don't have light, you don't have nothing. The generator is a vital component in a boat. And tomorrow we are going to start with the explanation about the generators in the classroom. Okay, right now it's clear that the voltmeter and the frequency meter are connected in parallel. The hotline of the voltmeter will be connected with the hotline of the frequency meter, and the neutral with the neutral. That's it. That's simple. Connect the frequency meter. Everybody follow the picture? You have question, guys?
Yeah. In phase 1 and phase 2, and let's say phase 3, do the donut always connect the same?
Exactly the same. If you have 3 phases, you have another donut and another group of gauge for volts, amps, and frequency. For what reason is important in a boat connect gauge per each phase? In your home, you have double phase. In your home, if you open the AC panel in your home, you have double phase, 2 phases. But you don't have ammeter, you don't have voltmeter, you don't have frequency meter. In the boat is very important. Why?
To make sure you have equal load on each phase.
This is number 1. This is the number 1 reason. Because you need to verify that the load is stable, is equal in both phases. That's the number 1. The second one, because when the boat is running, that power is coming from the generator. And you need to verify that both loads are equal in the generator to protect the generator. And you need to verify if the generator is producing the proper frequency. You need to verify if the generator, the output voltage of the generator is 120 or 110 if the boat is European boat. You need to verify exactly the voltage, exactly the amps, and exactly the frequency. If not, you damage the motors. What happens when the motors, the different motors, AC motors that you have in the boat are running with low frequency or high frequency? What is the symptom? The symptom easily is on the lights. You see the lights blinking?
Flickering, yeah.
Correct. And the other symptom is when you touch the case of the motors are too hot. Doesn't matter if the frequency is over or lower. Immediately the temperature of the motors increase dramatically. For that reason, the frequency, the volts, and the amps are mandatory. Can I install frequency, voltmeter, and ammeter in my home?
No.
Yes.
You could.
Yes, papi, you can. Buy the gauge and install the gauge in the panel. No problem. Yeah. It's exactly the same. It's exactly the same. No problem. You can install.
Mr. Lopez, I have a question. So is the donut always required? Is the donut?
The donut is required if you want to install ammeter. If you don't want to install ammeter, you don't need the donut.
It's not necessary if you don't want to install ammeter. Another question. I see in the drawing that you have the green wire and then the less green wire. Is it required to both have grounded?
Right now we are going to talk about the green wire because this is the other part of this conversation. Okay, in this particular case, this is about a double phase, and if you remember, the power for the main breaker is coming from the isolator transformer, and the isolator transformer receives the power from the output of the 3 breakers, and each breaker receives the power from the church, from the inverter, or from the generator. That part of the picture is clear, guys?
Mm-hmm. Yes.
Yes.
And you see in the output of the breaker how is the wiring, how is the connection?
Yes.
The hot with the hot and the hot, the neutral with the neutral and the neutral, and the phase 2 with the phase 2 and phase 2. And all of those outputs, the common of those outputs enter in the transformer. enter in the transformer. And you see the wiring of the transformer, the phase number 1, the black one, start on top, in the middle, touch the frame, the iron frame, and produce the neutral. For that reason, neutral and ground are connected at the source of the power. And after that, the winding continue red color, and this is the second phase. Everybody follow me?
Mhm.
Yes.
Mr. Porter, you follow me?
Yes, sir.
All right.
I'm sorry to bother you. Why is there only neutral in the H2, which is the hertz? And
No, you have neutral in both phases, in phase 1 and phase 2. You see the neutral in the middle?
No, but why don't you put it in amps? I want to understand that. Why don't you put it in amps too?
Excuse me, the ammeter, you say?
Yeah.
You have ammeter in phase 1, in the black one, and you have other ammeter, the red one, in phase 2, in the red one.
But why do you have the neutral only for the volts and for the hertz?
Correct. Because remember, in the ammeter in DC or AC, you need interrupt the hot or interrupt the positive and insert the ammeter in series. You don't need the neutral. You don't need the negative. You only need cut it the hot line and insert the donut to verify the flow of amps. That's clear? In both scenarios, in DC and AC, when you connect the ammeter, in DC, you use the chan. In AC, you use the donut. But you only use the hot line or positive line. That's it. Okay? The neutral is used to check the voltage because you need hot and neutral. And is also used to check the frequency because you need hot and neutral. No question, guys? Okay, try to refresh that picture. Take a picture of the screen of your computer right now, because after the conference you can check with more details the picture. Okay, I want that you verify in this picture the connection of the galvanic isolator. Where is connected the galvanic isolator, guys?
Ground wire.
Between your input on your boat.
In series, in the ground line. In series, you interrupt the ground line and you insert the galvanic isolator. Yeah?
Yes.
How you select the galvanic isolator? The capacity of the galvanic isolator, according with what?
Isn't it the capacity of the main breaker?
It is exactly the capacity of the main breaker in the AC panel. If the main breaker is 60 amps, the galvanic isolator should be for 60 amps. That's correct?
Mm-hmm.
Yes.
Correct. That is according with the capacity of the main breaker. Okay, guys. And now we are going to check a couple of things. One thing.
Question real fast. Question.
Excuse me?
On the galvanic isolator, you're saying it goes off the breaker. So if it's 60 at 60, you would not do a percentage up for that?
No, in that particular case, the recommendation is the same. It's the same in order to avoid that. A high current pass and enter. If you have exactly the limit of the main breaker, you interrupt exactly the same capacity. This is the idea. This is the unique element that should be exactly the same, not a little higher. Okay. In some cases, some technicians recommend a little less. I recommend exactly the same. Okay, I have other important question here. Is the connection of the breakers, double breakers, and the single breakers. For example, in the single breaker here, in the bottom, I connect the battery charger. Everybody follow me?
Mm-hmm.
Okay, the battery charger, the input is AC power, and the output is DC, and the output is going into the a.c.r. You remember that?
Yep.
In DC? Okay. And the input of the battery charger is AC current, 120 volts in this particular case, because the battery charger is single phase. Okay, one phase is coming from the breaker, one phase is coming from the breaker, the red one, that one, and the other is the neutral, and the other is the ground. The ground is connected with the ground bus bar in the bottom. The ground should be connected here. That's correct?
Yes.
Okay. This is the connection for the AC input. The hotline is coming from the breaker on the AC panel. The neutral is coming from the neutral bus bar, and the ground is coming from the ground bus bar. And this is the power entering in the battery charger, or entering in the computer, or entering in the blower, or entering in any AC equipment that you have in the boat, single phase. Okay, what about the output? The output is negative and positive, and each positive is going into the a.c.r. That's it. Check that in single phase, you use hot, neutral, and ground. Hot, neutral, and ground. The return of the current is through the neutral. Okay, now we are going to check on top the air condition number 1. You see the air condition number 1 here?
Mm-hmm.
The air condition number 1 is 240 volts. 240 volts. You have hotline black one, hotline red one, and ground. When you connect two-phase equipment, you use hot, hot, and ground. Hot, hot, and ground, no neutral. The neutral is exclusive for single phase. Everybody follow me?
Yes.
Okay. Neutral is used only for single phase. And equipment's double phase, for example, the air condition, the water heater, they use hot, hot, and ground. They don't use neutral for reference. They use hot.
So
Okay.
hot. You say hot, 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 and ground, right?
Correct.
For
Hot,
phase
hot,
2
and ground. Phase 1,
And
phase
then-
2, and ground.
and then for single phase, it's hot, neutral, and ground.
Correct. Hot,
And then-
neutral, and ground.
And then what about phase 3?
In phase 3 is hot, hot, and ground.
Hot, hot, and ground. So it's the same thing as phase 2.
Exactly. Exactly like phase 2. The neutral is only used in single phase.
Mr. Lopez,
Yeah.
I was thinking just now. So technically, if you have two hots and there's no return, how can you read the resistance coming from the AC?
No, really, when you have two hotlines, you read the reference in between one hot and the other one. And you don't have return, because the return is through the phase with lower voltage, with lower intensity. You have hot, hot, and ground. You don't need neutral when you have two phases. For that reason, this is a great question, my friend. For that reason, if you have a panel with double phase or three phase, you don't have the LED for reverse polarity. When you have a panel with two phases or three phases, you don't have the LED for reverse polarity.
Is it because it's only neutral?
Because the reference is with ground, not with neutral. You remember that light, the light that we connect for reverse polarity, guys, in single phase? You remember that or not?
Yes.
Yes, sure. Let me try to check quickly. Okay, guys, you see what is the situation when you have a single phase panel and you have the reverse polarity indicator. Where is connected the reverse polarity indicator? One leg connected
Neutral
to
bus
the neutral bus bar. and the other leg with the resistor connected to the ground bus bar. Okay. What happens if you make a mistake and you switch the hot and the neutral at the input of the breaker? What happens in that case?
Powers the light.
Correct. The neutral will be powered and the hot will be neutral. Okay, if the neutral is powered, is hot in this moment, what happened with the light?
Always on.
The light is on because you have power on the actual neutral bus bar, and the reference is the ground, and you have the light on. For that reason, the reverse polarity indicator should be connected in between the neutral bus bar and the ground bus bar. And what is the function of the reverse polarity indicator?
To let you know that it's not reverse.
Okay, identify if you switch the hot and the neutral. There are two different ADYC questions related with the same reverse polarity indicator. One of the questions is, where is connected the legs of the LED? One leg into the neutral and the other one into the ground bus bar. That's one question. The other question is, what is the function of the reverse polarity indicator? Indicate if the neutral and the hot are switched. In that case, the neutral will be hot. That's correct?
Yes.
All right. And this is the situation in single phase. In single phase, I have the reverse polarity indicator connected into the neutral and the ground bus bar, and the leg with the resistor, 25 kilo ohms, is located in the ground bus bar. Okay, let me stop this, and we are going to return to the previous.
What's the point of the resistor? What's the point of the resistor if it's still going to receive power?
Excuse me?
What's the point of the resistor if it's still going to receive power? Is just to lower it down?
It's because the reverse polarity indicator is an LED, is a diode. This is to protect the diode. If you switch the legs, immediately the LED is burned. Okay? It's to protect the diode that the indicator is a diode. LED, reverse polarity indicator diode. Okay, my friends, this is the situation. Okay, we are going to continue here with the connection of the air condition number 1. The power coming in will be hot, and ground. And what about the other green? The other green that we have that we connect to the bonding system. It's different wire, and this is for that reason I put in a different intensity of green. That cable is connected to the bonding conductor, and the bonding conductor at the end is connected to the sink. And that cable is coming from the frame of the equipment. In this particular case, is coming from the frame of the air conditioning system. And the other green, the green in the left side, is connected with the ground bus bar. You see, with the ground bus bar. Of course, at the end of the day, the ground bus bar will be connected with the bonding also. But in terms of connection, you have two green cables. One green cable coming with the power, hot, and ground, and other green cable going from the housing of the equipment into the bonding conductor. Everybody follow me?
Yes.
Okay, all the equipments have the same situation. For example, we are going to check the water heater in the bottom. The power coming in to activate the water heater is hot, and ground. And from the case of the water heater, we have another green cable connected to the bonding conductor. Good? Guys?
Yeah.
Okay, and this is basically the wiring of an AC boat double phase.
So with the bonding system, right, that we're talking about for phase 2. So with a single phase, it would be the same bonding system.
Exactly the same. All the metallic elements, doesn't matter if are AC powered or DC powered or no powered. If it's metallic, should be connected to the bonding conductor.
So basically, you're saying that only because if it's metallic, it should always
correct. It should be connected to the bonding.
But
not because it's double phase or single or AC or DC.
Okay, but if it's already grounded, it should be okay. But only if it's not like all right. As long as it's metal, it has to be bonded. Okay, I got it.
It is metal. It is metal. Yeah. It's clear, no, Danny? What do you think, Danny?
Absolutely.
And it's not complicated.
No, it's not. It's not complicated. You just gotta think of how everything's routed. That's the one thing. You gotta take DC out of your mind when you're dealing with AC. It's just
correct. For that reason, tomorrow we are going to talk at the beginning of the class about this. Immediately, guys, you receive a phone call. Immediately, you receive a phone related with electrical problems. You need to ask a couple of questions to the customer in order to isolate the problem. To isolate if the problem is DC or if the problem is AC. Yeah? You need to identify, okay, my problem is DC. I will be concentrated in the batteries, in the battery switch selector, in DC. The problem is AC, okay. And let me check, it's probably on the pedestal, it's probably on the generator, it's probably on the inverter. Let me verify where is located that AC problem. Of course, if the problem is AC, you have more sources for the issue. Yeah.
There's a question in the comment.
Excuse me, in which one?
The comment. Hold on, let me pull it up. Does the ground bus bar connect to the bonding system?
Yeah, the ground bus bar. Let me do the sorry, I make a.
Yeah, I didn't see that. I didn't have it open.
Yeah. Let me, I do the. Yeah, the ground bus bar. The ground bus bar will be connected to the bonding system. And if you have the DC panel, the negative bus bar of the DC panel should be connected to the bonding conductor and the sink. For that reason, other of the ABYC question is, what is the, excuse me? Other of the ABYC question is, what is the only element in common in between the DC panel and the AC panel?
Ground.
The bonding connection. The connection in between the ground bus bar of the AC with the negative bus bar to the DC into the bonding conductor. The grounding or bonding is the common element in between both panels. That's correct?
Yes.
Guys, you follow me?
Yes.
Okay. My friend, this picture looks simple, but it's not simple. It's a lot of concepts condensated in that simple picture. Okay, I have another question. Suppose that the captain of the boat say to you, I want to install another voltmeter here. Let me try to change the colors. How can I change the colors here, Diego? Oh yeah, sorry, it's here, yeah. The captain said, I want to connect another voltmeter in order to reach 240 volts. How should be the connection of that voltmeter?
Both black and red going into it.
Correct. I need one black line here, and other red line here. Could be at the input or after the breaker in order to reach 120 volts. This is very, very, very important. It's clear,
Okay,
my
so there
friend?
would be no neutral on this voltmeter?
No, my friends. Once again, when you read two phases, you read in between one phase and the other one, and you see
Okay.
the potential difference between both of them. Neutral only in single phase.
So this hold on. For this voltmeter, right, is to read both of the voltmeters together into one.
This is to verify if you have 240 in between both phases.
All right.
This is only to verify if both phases are okay. This is an important voltmeter, the voltmeter both phase, because when you have a double phase panel, it's very common this problem. The customer says, in my boat, the generator is running. However, one phase is 180 volts and the other phase is 80 volts. One phase is too high and the other phase is too low. And normally, what is the inconvenience in that case, in that situation?
You don't have enough power, right?
No, because if you check the gauge of the 240, you have 240. But if you check the voltmeter of the phase one, is 180. If you check the voltmeter of the other phase, is 80. One phase is too high and the other is too low. If you read in between both of them, you have 240. You understand?
Yes.
What is the problem in that particular case, guys?
I want to say bad wiring.
Uneven load.
Let me show to you. It's this. Let me show to you.
It's not reading right?
No, let me 1 second. Let me 1 second, please, guys. This is the situation in that particular example. Okay, it's here. This is the picture. Look at this picture. Look at this picture. In the phase number one, in the transformer on top, you have 120 volts. In the phase number two, you have 120 volts. In the bottom, you have on top 60 volts. In the bottom, 180. Oh, if you read between both of them, it's because the neutral is broken. This is other ABYC question. What happens if you have high voltage in one phase and low voltage in the other one? Is the neutral is broken. The neutral is, and this is the example. Remember me, tomorrow in the board, I am going to explain that picture. That picture is difficult for some people, but it's too simple. Remember me, tomorrow in the board, I explain again that board. Okay, guys? It's neutral broken. The neutral is broken.
Mr. Lopez, I have another question. So when you're wiring a panel, right? Shouldn't it always be black first and then the red one second coming in?
No, not necessarily the second.
Because
they could be in different order, but one is phase, other is neutral, and other is ground. Suppose, my friend, this is a great question, Marcus. Let me explain why. Because in some cases, the both, they don't have the color code. And you have all the cable with the same color. And you need to verify which one is the phase and which one is neutral and which one is ground. And you need to use your voltmeter in volts AC. And you read in between two cables. And if you read in between two cables 240, is because you have hot and hot. If you read in between both cables 0 volts, is because you have what?
Neutral or ground.
Neutral and ground. Yeah. Okay. Now you need to identify which one is neutral and which one is ground. How can you do that?
I don't know. I know. All right. So you connect hot and hot with the ground and try to see if you get some kind of.
You remember that I explained that normally in the outlet in your home, if you check the voltage in between hot and neutral, normally is around 120. And if you check the voltage in between hot and ground, it's a little lower. It's 119.2. That you understand?
Yeah. So
Okay. In that case, this is the ground, and the other one is the neutral. If you read in between neutral and ground, normally it's 0.007, 0.003. It's practically zero. Yeah, this is the procedure. With the voltmeter, tomorrow, remember me, with the extension cord, I explained that procedure.
But that's why that's in a boat that's unorganized. But usually in a boat that's organized, you should color code it, put black first, red second.
Correct. You have normally, if the boat is American, you have black for one phase, red for the other phase, white for the neutral, and ground for the ground line. If the boat is American boat. If the boat is European boat, you have brown, blue, and green with yellow strip. Brown and brown for phase 1 and phase 2. In some boats, European boats more organized, they have brown and gray for phase 1 and phase 2, blue for neutral, and green with yellow strip for ground. That's okay? Guys, you follow me? All right.
Yes.
Okay. Don't forget, this is the color codes for European and the color codes for American. My friend, check your book, because you have a lot of information in the book, and check the ABYC question, because on a Thursday, after in both days, tomorrow and Thursday, we are going to solve an ABYC question with Mr. Rodriguez. When I explain my explanation at 9 o'clock, you continue with Danny solving ABYC question. Tomorrow we are going to start in the question 51, and we are going to continue until 100 if it's possible. And on Thursday, we are going to continue in 100 until 150. And after that, the last week we finish. Everybody clear, my friends? For that reason, be prepared with the questions 50 until 100 for tomorrow, because tomorrow we are going to solve those questions in the second part of the laboratory.